This class is called computer science. So besides learning how to program, we want to understand what's going on and how programming languages work and interact with the operating systems and all that sort of stuff. So one thing I always find interesting is I picked Python, Java, and C++, or I should say we picked them because they're the most commonly used classes in universities. And if you look on the popularity pages, you notice that Python, Java, C++, those three are always right up in the top. Java is used primarily for web servers. C# is primarily used for web servers. JavaScript is primarily used in web serving. Python does a little bit of everything. So we're working the, three of the biggest languages around, which is good. All right, so there's a couple of books that I would not hurt to read through and look at. And I have the links in here. You can link into them and hopefully they still work and they haven't disappeared. If the pages have disappeared, let me know. I'm not going to go through that, but I am going to go here. How does Java work? Well, we know that our program that we type in is just text, right? So somehow we have to convert that human text into ones and zeros, binary. And so Python and Java kind of do the same thing. You have your development kit or whatever. Java compiles the program to what's called bytecode. The Java runtime environment runs that bytecode, and when it executes it, it converts it into binary so that the virtual machine can understand it. Did I say that right? Yeah, pretty much. So the dot class is a Java executable. The Java virtual machine converts that. Yeah, I said that wrong. Java virtual machine converts that into binary so that the computer can understand it. Because computers can only understand ones and zeros. They don't understand maybes. Now, how does Python work? Well, we have a text file with code. We have the Python interpreter. And then it talks to the Python interpreter talks to the operating system. So Python at this time doesn't compile anything. It's basically a scripting language run through an interpreter. That is changing with the newer versions of Python. They're looking at making it more like this, so it actually compiles to a bytecode of sort. And some of it does right now, but that's why Java is so much faster. With the same program, Java will outrun Python any day of the week. But Python is very flexible and friendly. All right, so all programs have input, process, output, right? No problems there. Now, one thing that's different between Java and Python is that we now have data types. We have to say this variable is going to be an int. We have to say this variable is going to be a double. We have to say this variable is going to be a string. Those are our three common types that we'll be using. And in Java, we use doubles, where actually in Python, a float is a double. Uses the same memory space and has the same amount of digits. So float and double mean that we're using 15. I mean, in Python, it says float, but it's a double. Here we call it double. It uses 15 decimal digits of precision. So a computer cannot actually do a fraction. It can get close, which is why it's called a floating point. So why it's called a floating point is, I should bring up a big text thing, because this is some of the computer science part. That is the understanding conceptual thing. Oh, we don't need my secret password. Let's zoom in a little bit. All right. So if we have a number 1.2, that has 2 points of precision. If we have 2.3, that has 3 points of precision. So when you're talking about the points of precision, it also is talking about this guy here. So if we have 0.1, 2, 3, 4, 5, 6, 7, 8, 9, whoops. 9, 10, 11, 12, 13, 14, 15, 16. That's how many points of precision we have with the double. After that, it rounds it off. Because it can never be exact. if we do 1, 2, 3, 4, 5, and then we add in 16, that's still the same amount because it counts both sides. So notice how the decimal floats back and forth. So if this were both 16, they'd have the same amount of precision. I might not have typed it right. So it floats back and forth. So that's called floating point math. Computers can do integers way faster than they can do floating points. So the supercomputer, interestingly enough, they had like an entire rack of NVIDIA graphics cards, because you know what graphics cards are really good at?
Calculation.
They're good at what?
Calculations.
Calculations of what type? Floating point. They're really good at floating point. They're better than a CPU is, which is why Bitcoin mining uses graphics cards. Because their processors are really good at floating point. They can do it way faster than a processor can, because they're specifically designed for that. Anyway. Let's see. Oh, they do mention here, which I thought was interesting. A computer can deal with this level of precision faster than this level of precision because it's built into the processor to do that. Because we're using what's a CISK, complicated instruction set computing, where our phones and Raspberry Pis use RISC, reduced instruction set, which means that we can have computers that are very small and very light and very cool, where Intel has all kinds of more circuitry, or AMD, and they run hotter. And actually, that's the Apple M chip, is a RISC chip. So at some point, my guess is we're gonna all end up on RISC, which does mean that the operating system has to take over more of the load. Because reduced instruction set, means there aren't as many shortcuts in the CPU to get things done. Does that sound pretty computer sciencey? That's what we're here for. Anyway, we probably should actually do some programming too. So what I like to do, and I've discovered for me, the best way to work with Visual Studio Code is to find a folder that I'm going to make the program in. Let's just say I'm going to go into Documents, and I'm going to make a folder called Java. I like to organize things. And then I'm going to put all my Java programs from week 1 into a folder called week 1. What I don't want to see, especially from second-year students, is all your programs in one folder. No, no, no. Have folders however it organizes for you. As an instructor, I like to organize things by week, just because that's how we teach it. So you want to start, if you haven't, start organizing things. So I have my week 1. Oh, there it is. If I right click on week 1 in Windows, I get nothing of what I got in Windows 10, which sucks. I have to go to show more options, and there'll be an open with code. So when you open a folder with code, it kind of creates an on-the-fly project. And if you don't have open with code, that means you didn't pay attention to my directions. You can also, from inside a Visual Studio Code, once it's running, you can go to File and open a folder. Opening a folder is the best way to use, because it creates a little on-the-fly project for you. So if you can't right click and open the folder, and it's going to come up with this: do you trust the authors of the files in this folder? So it's asking, do you trust yourself? Do you trust yourself, Andy? No, he's yawning, so he doesn't trust himself, but I trust myself. You can also go to File and open a folder. And it's not as important right now, but as we get deeper and further into things, it will make more of a difference, because we will start dealing with, instead of one file in a program, we'll start dealing with multiple files. All right, I do not need to see this anymore. All right, here we are, week 1. Are we ready for the next step? Everybody good? If not, let me know. Ask questions. All right, so I'm going to, you can click up here, new file. You can right click, new file. And we're going to name this according to the Java convention, which is, I think it's called Hungarian case. Anyway, it's capital lowercase, then capital lowercase dot GAVA. Java is the extension for the source file for a Java oh, sorry, Andy. There, I usually zoom this in when I'm working on that. Is that better?
Yeah, better.
Yeah, you could always come up here between Mikhail and Matt. They're very friendly. They don't bite.
Yeah, maybe there's some.
Okay. So when we do hello world.java, it should pop up and say, oh, do you want to install the recommended extension pack for Java? This allows us to run and compile our programs from inside of Visual Studio Code. If this doesn't come up, which it might not, I think I zoomed too far. I can't even use my program. There. If that doesn't come up, if you go over here, there's a little spot that says extensions. And there's, I don't know, there's got to be 1 million extensions for this thing. And I'm going to type in Java. And the extension path from Microsoft is really all we need. And it's been downloaded 29 million times, so I think it's pretty decent. So that installs the extension. And it'll just take a moment to download and install. Now we have Java language support inside of Visual Studio Code. Just like we did last year with Python, we installed the extension for Python. We'll install an extension for C++ once we get there. Okay, part of that is I have to accept some stuff from Red Hat. Okay, and I think we're done. Yep, we're done. Close out that. Close this, there. And if you notice down here, it's going to say Java activating. Well, it's creating a little on-the-fly Java project. And it has, oh, I never noticed it had a coffee cup down there. That might be something new. That's pretty funny. It's always nice to be easily amused. How are we doing? Are you good, Sonia? She shook her head. Andy didn't shake his head yet. Are you at this point, Andy? Did you get stuck? Thumbs up? All right. So, yes, I'm not going to do all this, but I am going to do the big important parts. Commenting in Java is, that's single line commenting in Java, 2 slashes. Now, when we get to C++, you'll notice that C++ and Java are very similar. Most languages are different than Python because Python was designed to be a very easy language to learn, so you don't have curly braces and all that. In the program, I have a /star, wherever my star is, and then notice how it automatically made the other one for me. That's part of that extension pack we added in. And now I have multi-line comments. You know, so I can put in the name of my file, who I am, when I wrote it. And anybody who's been in a class with me before, you know I am very fond of commenting. I will at least several times in a year go, okay, I commented this program really well when I wrote it, but I have no idea what I was thinking now. So your commenting is to keep your future self happy. And other people you're working with. All right, so in in Java, we always start out with public. We have to specify the access. And everything in Java is a class, and you have to say that it's a class. Where everything in Python is a class, but you don't have to say it's a class. It handles all that in the background. So we have public class, and we have to name our program the same as the first part of the file name. So if your file is named Hello World, it has to be named the same thing, upper and lower cases have to match, or it'll tell you something's wrong. When you put in the left curly brace, automatically the next part of it is put in by Visual Studio Code. So I'm just going to press the Enter key, and it's telling me something. Oh, it is something wrong. I forgot to put the L in there. There. See, I told you. It'd give you a red squiggly and shout at you. Now we're good. We have our public class, that's the outline of our application or program. So far, so good? Now, this is all handled in the background in Python, but in C++ and Java and many other languages, you have to put it in explicitly. Explicitly meaning you have to put it in, not the programming language doesn't do it for you. Another thing you have to put in with many other languages is you have to say where the main method is. The main method is, we used it in Python, but we didn't have to. Sometimes we did, sometimes we didn't. If you don't use the create a main method in Python, it creates one for you. Well, Java doesn't do that. We have to do public static void, which we'll work on that later. Basically, you just type in exactly what's there, and that starts out our main method, and we'll go through what all these wiggly things mean later on. For now, you know that this is the boilerplate for it. So instead of typing all that in, if you can remember public static void main, there's a little expansion thing there. That's how it brings up PSVM. If I press tab, it types it out for me and puts in the curly braces. How about that? That's called, I think, like an expansion macro or something like that. So this is saying, this is the executable part of the program that will run when you compile and run the program. So all programming languages that I've ever used have a main method of some sort, which starts the application. And then we have there's our little comment. We're going to print a string literal. Does anybody know what string or literal means? I know Mikhail does. What's a string? What data type is a string?
Text.
Yep, it's text. How about literal? What's a literal? They know what a literal is?
Characters.
Literal means that literally you've typed it in, it's not a variable.
Okay.
So if you have a double, it's also like a constant, meaning you've typed it in, it's not gonna change. So we do system, which is the operating system, dot out, which is the direction we're going. Remember, programs and computers have input, output. So we're saying the operating system out. We're going out of the program into the operating system, or the operating system dot out dot print ln. So in Python, we just said print, but in the background, all this stuff was there. Not exactly this, but it was that type of information was there. And then just like in Python, all strings are surrounded by double quotes. Hello world. Oh, and then it's giving me a red squiggly. Well, C++ and Java, we have to end everything with a semicolon. So if you remember Intro to Robotics, when we're working with Arduino C, this is the same syntax. And I don't want to type all that again. So I'm very much in favor of copying and pasting and then modifying. But the answer is 42. What's the question?
What's the meaning of life, everything?
Every geek has to know that.
Most important question in the universe.
That's right. That's the most important answer. So now who can tell me what 42 actually means? I always do this with classes. So 42 has an actual meaning. It's not just the number 42. Oh, I'm diving deep, aren't I? So 42 is the ASCII character for star, which star is the wild card. So literally 42 means everything. So the answer to life and everything is everything. So for instance, I didn't make that up. If I go to, what is that, character map? The computer does not understand letters and numbers. What does it understand? Ones and zeros. And I don't know where it is. It's in here somewhere. Anyway, I'll just pick this. I'll pick it in the 5. So down here, 0035, would be converted to binary, and that's how a computer stores a number. So if you found 0, yeah, I don't know if you can search for 0042, but if you found 0042, that would be the asterisk, which I don't find it, but,
It's in the top row in the middle.
oh, there it is. See? Oh, this is Unicode, so this is ASCII, those are two different ways of doing it. So it's actually 42 in ASCII, but it's 002A here, which is not near as funny. I don't know how you make this do ASCII.
Maybe advanced view. Yeah,
Ah, here then we can change it to, should have ASCII in here. Oh, I guess not. Well, regardless, that's a whole bunch of stuff we don't need to get in. We'll get into ASCII and Unicode and all that stuff later, but not now. So my program has no wiggly stuff in it. If you want a challenge, do this program in Notepad, which we will do that kind of stuff later. A couple of ways to run the program. You can hit the little go button up here, run Java. It should then, the first time around, you'll want to allow. We're not really accessing the network, but I think if you don't allow, it's gonna come up every single time. And there it is. Hello world, the answer is 42. We just printed to the console. How about that? I know my Java development environment works. And my program was successful. And then we have tutorials and other things. So let me